Hello there. So let's take a look at Maclaurin series, and we're going to look at a very simple example. Before we look at the example though, let's take a look at what we have so far. So the following is the given formula for a Maclaurin series. So f of x, so this is in a Maclaurin series approximation for a function f of x. So we will evaluate the function at 0. So we will evaluate f0, this is my first term, plus x times my first derivative evaluated at 0, plus x squared over 2 factorial times my second derivative evaluated at second derivative at 0. So what we need to do first is, for any type of Maclaurin series, we need to find the first derivative, second derivative, or if it is necessary, the third derivative, and evaluate all of them at 0. Just for some background information, a Maclaurin series is actually a Taylor series with x is equal to 0. That is very important. And then, of course, these are given Maclaurin series for special functions, as they say. So e to the power of x, the natural log of 1 plus x, sine of x, cos of x, or tan of x. We will look at these in a little while later. So the following example we will solve with using two methods. So let's go and take a look at the first method. So let's go down to the question. So this is a relatively short one supposed to be. So find the first three terms of the Maclaurin series for natural log 1 plus e to the x. So what we can do if we wanted to start early or easy is, we could have said, sure, let's find f of x. Let's find f dash of x. So the first derivative of f of x, we're going to find the second derivative of f of x, or maybe the third derivative of f of x. So f of x is given natural log 1 plus e to the power of x. My first derivative, in this case, if we were to find the derivative, would be e to the power of x over e to the power of x plus 1. Then my second derivative will be e to the power of x over e to the power of x plus 1 whole squared. And then finally, I'm going to scroll slightly down more. Finally, my third derivative would be, now it is not really necessary to go this far, but I'll talk about it in a while, and I'll give a reason why we are doing this. So negative e to the power of x times e to the power of x minus 1 all over e to the power of x plus 1 cubed. Okay. So we have f of x, first derivative, second derivative, third derivative. Now what we can do is we can evaluate when x is equal to 0. So if x is equal to 0 in my first case, anything raised to the power of 0 is 1. So this will become ln 2, natural log of 2. The first derivative at 0 is going to give us a half. The second derivative at 0 is going to give us 1 over 4. And the third derivative at 0, if we evaluate it, would give me a 0. Now, they say find the first three terms. Normally, they could also ask for the first three non-zero terms. And that's why I did evaluate this one extra, just to show that sometimes when we do evaluate a derivative at 0, it could be 0. Therefore, this one here will not be a term. All right. So now we have f of x. We have the first, second, third derivative all evaluated at 0. Now let's go and take a look here at our Maclaurin series. I'm going to zoom out slightly and then let's go back up. So for a Maclaurin series, we can use this formula. So we will first say f0 plus x times the first derivative at 0 plus x squared over 2 factorial times the second derivative at 0. So here I can now go and write f of x is equal to, so f0 in our case is natural log of 2 plus x times the first derivative at 0, which is a half, plus x squared over 2 factorial times my second, which is 1 over 4. If I simplify this, natural log, and of course dot dot dot, because this is still going on, plus x over 2 plus x squared over 8, dot, 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 as this is continuing. So there I have my Maclaurin series, or more importantly, I have the first three terms of my Maclaurin series. Now, there is an alternative method, and that alternative method is when we are going to use the following. We have e to the x, and we have natural log of 1 plus x. So let's go down slightly, get some more space, and let's start writing. So I'm just going to quickly rewrite here what is important. So e to the power of x can be approximated as 1 plus x squared over 2 factorial, continue. Then natural log of 1 plus x can be approximated as x minus x squared over 2 plus x cubed over 3 minus etc. Now, what they ask us to find is natural log of 1 plus e to the x. Now, this is actually a composite Maclaurin series. That means that one series, e to the x, will go into composite function into natural log of 1 plus x. So e to the x is now going to go into the position of x. So if we want to do this, let's first go and rearrange and play around with this natural log 1 plus e to the x to make it slightly more familiar what we have. So we can say the following, all right? So we have a natural log, then we have 1 plus. Now let's go and substitute in e to the x, the approximation. If I were to go and replace e to the x substitute with my approximation, I will have 1 plus x squared over 2 factorial, dot, dot, dot. Remember, we only want the first three terms, so I don't really have to approximate any further than this. If I were to expand this, so this will become natural log of 2 plus x squared over 2 factorial, etc. Now, in this case here, this is not really what we want to be playing around with because we want natural log of 1 plus x. So I need to factor out a 2. So what we're going to do in this case is natural log. Now, if I factor out a 2 here, this will become 1 plus x over 2 plus x squared over 4, etc. And when we have this, a natural log, so remember with logarithms, if I multiply something, I can say this becomes natural log of 2 plus natural log of the remainder with the addition law. So 1 plus x over 2 plus x squared over 4, etc. All right, let me scroll down slightly just to get some more space. And then let's start expanding this natural log series here. So this is equal to natural log of 2 plus. Now, in this case, for this series, it is ln of 1 plus, and then each one of these. So if we want to use this series expansion, as you'll remember, I can substitute this into x for ln 1 plus x. If you remember, ln 1 plus x is equal to x minus. So this is what we have here, x minus x squared over 2. This is my series expansion for natural log of 1 plus x. So I am now going to use that series expansion of 1 plus x, and I will now replace whatever I have here on the inside in the place of x. Okay, so instead of x, I'm now going to have x over 2 plus x squared over 4 plus etc. Now the second term for ln, remember, it was natural log for 1 plus x was first x, so this is just the x value, and then it was minus x squared over 2. Now we don't have an x. What we have is this is in the place value of x. So this will become x over 2 plus x squared over 4, etc. And now let's go and expand this further. So natural log of 2 plus x over 2 plus x squared over 4 plus, of course, this will continue here, minus. Now, if we were to square this bracket, so just imagine two of these brackets multiplied until nearly positive infinity. So x over x2 is going to multiply, and this is going to give me x squared over 4. Of course, all of this is still over 2. Plus, now if I were to multiply these, I would get an x cubed. And at this stage, we are not interested with an x cubed because we only want the first three terms. That will mean a constant, x to the power of 1, x squared. So this will give me natural log of 2 plus x over 2 plus x squared over 4 minus, and in this case here, this will become x squared over 4 divided by 2, which will give me x squared over 8 plus positive infinity. Nearly. Okay, so natural log of 2 plus x over 2 plus, in this case, 1 over 8 x squared.